Well, it's time to pull the F-14 down, the small size F-14. This has been in the backdrop for a while, and we're gonna yank that plane down, and we are getting started. We're fresh back from Turbines and Tumbleweeds in Sweetwater, Texas. We've cleaned up the shop, it's build season, and it's time to get started on that. So you never saw an unboxing for that aircraft because that aircraft came to us just like that on the foam stands. So we're going to pull that down, lay it all out, and we will take a look at all the equipment going in that plane. All right, so we got everything laid out. We're gonna take a look at all the equipment and everything. It's funny that now we call this size aircraft, which is still very big. We call this the normal size F-14 because last year or the year before we did the XL version, and now we're doing the normal size version, which is funny. It's still a very big aircraft once you get it down. You may notice the hoodies. We did up a special run of shirts and hoodies. We still have some left from Turbines and Tumbleweeds. So if by chance you are interested in this hoodie, and also we've got some cool t-shirts as well too, definitely shoot me a message. Best to email thelightersideofrc@gmail.com, and we'll see what we have left. Hoodies, we've got a fair number left, but shirts, there's not many left, but there's some cool shirts. So anyways, let's take a look at all of our equipment going in this aircraft. All right, so the owner of this aircraft, he purchased it from Robzilla Smith. If you guys are on the forums and stuff, he'll recognize his name. And some of the stuff came with the aircraft, and some of the stuff we've ordered since having the aircraft here. So we'll take a look at everything. Now we're building this one very similar to the one we did 4 years ago. That was the last time we did a standard size F-14. It was right when we were moving into the shop and our new house and everything. So it's going to be nice to be able to do one of these guys again. And one of the cool things that is different on this one is we've got the full ordnance package. So we didn't have this on the previous little F-14, but very nice ordnance package. We've got the swing wing out of the aircraft, and here are the rest of the ordnance stuff. A lot of this stuff's going to be very similar as far as setup goes. We're going to be using the same program. We're using a Jetty radio system, of course, to fly the aircraft and everything, so that's going to be very similar. So let's take a look at all of our equipment. All right, turbine-wise, we have two Swewin 190s. Those have been provided by us here. We've got a full lens set as well, too. So some of these still need to be shaped, but these are the lenses for the lighting system. So those are all done. We've got the Unilight scale lighting system, F14 1/8 Pro, so that's the same as what we used previously. We've got the afterburner lights as well too from Unilight. These are the Bad Mama Jammas, the powerful ones, and the afterburner controller, so that's cool. Jetty stuff, we've got two Rec 7 receivers, M-speed sensor, R3 for on-off. We've got a central box 400, so and of course a Cortex. So this is kind of all the normal setup that we're going to be using. Servo-wise, very much the same as what we did previously. So we've got 737s, 747s for the leading edge. We've got 599s, 9930s for the rest of the aircraft. We've got two Actuonics linear actuators. So these are the upgraded ones, I believe. So we've got an L16, 100, 150, 6R. So what does that mean? Well, the stock actuators are Actuonics linear actuators, but they are L16, 100, 63 is the difference. So what that means is 100 is the stroke length here, and of course these are made in Canada, but 150 is the gear ratio. So the stock actuators, we had the same problem on our previous ones. The stock actuators come from Skymaster and they really don't work that well. So it comes down to the gear ratio. So they extend, I think, in about 4 seconds, but if there's any pressure on the leading edge of the wing, they just don't extend. So we ended up on the previous one going to the high ratio ones, and I believe we actually tried the middle of the road ones, so the 100s. But the 150s take about 8 seconds for full swing, and they are much more powerful. So that's what we're going to be using in this aircraft. The air system is going to be all controlled by Chicoy valves. We've got two-way valves everywhere, a single brake valve. We've got a sequencer, and this is the canopy actuating stuff along with the tail. We're going to be putting an onboard compressor, so we've got a V-speed compressor as well. This is the stock hardware package, so that's good. Battery-wise, now this is kind of an important one. When we ordered the batteries for this aircraft, now we've got quite a few scale planes coming for the owner of this aircraft. Chris has a bunch of scale aircraft en route to us. And the important thing about these batteries is we don't need to have batteries for every single airplane. So the way we operate things is typically with a scale aircraft we try and keep the battery layout the same. So this aircraft is going to have 4 of these 4,000 milliamp batteries, and that will work for his A-10, his F-14, and any big scale planes in the future. So he did end up buying the F-18 that we had listed here on our website, and that had some of these batteries in there as well too. So then we've got this aircraft which has 4 of these batteries, and he can just juggle these between all of the various aircraft. So that's why we do it. And the Central Box 300 series, 400 series, they reduce the power down to whatever you want it to be. So in this case, we'll have 12-ish volts going in, and we'll have the power reduced to 8.4 volts for the entire system. So it's a nice, great way to run aircraft and keep your battery layout simple. And to touch a little bit more on the battery situation, we basically have, I think, 3 batteries that we use that power all of the aircraft. So all of my fleet, they take 3 batteries. We've got a 3-cell 4,000, a 3-cell 5,000. Those are used in the single battery planes like the Picarito, the Falcon, which is behind there. So anytime we're using a single battery, we're using a 3-cell 5,000. And then we've got 2-cell 5,000s, which go into like a Central Box 200 series. So that's the battery setup. Of course, we have Warbird pilots as well too. I don't know if there's a randomizer. I don't think so we may have to order up a randomizer for this aircraft. Now all of the landing gear have been taken out of the aircraft, and these are the struts by Michael Brown. So these are the struts with the built-in locks right there. So, or at least I think these are the ones, and the stock ones are still on there. But anyways, we've got the locking struts. Very important for this aircraft, because if you don't do that, the little air cylinder ends up destroying itself. Stock air cylinders, we've got those. I will only end up using 2 on this aircraft because of the V-speed compressor. This is all the cockpit stuff, and of course we've got the manual and some stuff. The entire aircraft is protected by Revic bags. So we've got a Revic tail set, we've got a Revic rudder set, and that came with the aircraft. So those are ordered previously. That's why they don't say my logo on them. And this is the scheme. So very, very cool. Looks awesome. It's going to be a very nice looking F-14. So in its simplest form, that is all of the equipment. Of course, there's going to be more stuff here and there. The aircraft is going to be piloted by Jetty radio system, and we will be using Powerbox power wire everywhere, as well as Powerbox ends for all of these servo connections. So that's the nuts and bolts of this aircraft, guys. First thing we need to do, like always, is update our receiver setup and all of our Jetty devices. So we're going to plug those into our computer. We're going to get those updated. I also need to get the previous program for the F-14 onto my radio. So we did end up selling our Gen 1 DS-24 while we were in Texas. Congratulations, Phil, on that. And so this blue one, which was my first Jetty, is now our shop radio, and all my aircraft are going to be flown on my purple one, which I'm excited for as well too. So this is what we're going to be setting this aircraft up on, and we're going to put our program from our computer from the previous stuff onto this radio. All right, so I'll do a little quick dive into the programming on the F-14. Now the F-14 programming is definitely the most complicated programming around, and the reason for that is you've got the wing sweep, different flight modes. We have done, well, the owner of the previous one, David, has done a ton of programming on this aircraft, and I think the program we originally used 4 years ago was from a previous generation F-14. So there's a lot of safety features built into this. So I'll give you guys a quick overview on everything. We won't do a deep dive into this, but this will at least give you an idea of how things are working. Now, when I do a setup like this for a customer, I've got their switch layout. Now, so their basic switches like gyro on off, flight modes and such are predetermined, and there's all the other stuff that's already been done in this program. So we'll take a quick look at it. All right, so one of the big things is flight modes and wing sweep. So we've got a couple things going on here. I'll just kind of give you a quick rundown of how we're doing it. So we've got our flight modes here on SD switch. So that's flaps or flight modes and flight modes.
Cruise mode.
Now, for the wing sweep, we've got it set up on SC. So if gear's down, wing sweep does not work. And to prove that, we'll go into the settings here for swept wings, so 100%, and it won't move. With gear up, wing sweep does work as long as we are in regular flying mode. And then there's also an override switch on the back here, so we're using SM as the override switch. So let's say we're on the ground and we want to do our wing sweep. We flick that switch, and now we have the ability to sweep our wings. So there's a whole bunch of programming going on there to make that happen. So I'll give you a quick rundown of how we've done that or how it's been completed. So the first thing is all the logical switches. So if we go into our advanced properties, we've got logical switches. So we basically have wing safety 1, wing safety 2, wing override, wing safety 3. So those are all tied to the wing sweep. So that just comes down to stacking logical switches. So when we stack logical switches like that, logic 1 needs to be working for logic 2, in logic 3, and logic 4, and so on and so forth. Now, when we take this program from a previous radio, the owner's got a different layout. When we put it on the new radio like this, there's some fudging we have to do or some fixing we have to do as we go through this. So that's the things I've been working on now, is just making sure that everything kind of ties together. But ultimately, as we go through the plane, that's what we're going to be taking care of as we get things set up. If your wings are out on this aircraft, getting to this pin can be difficult. So that's why you need an override to be able to pull this pin out. Now, we have been able to take it out, but it's not super easy. So when the wings are out like this, this kind of interferes with the wing. And you want access to this because this is where we do our fill, where we do our air up and stuff like that. Also having your turbines visible here when you're starting up is a good thing. So generally what we want to do when we want to open this up is we want to sweep those wings back, pull this pin out, open this up, and then when we're done and ready to close it up, we can close it up with the wings back, push this in, have the wings come back out, take our override off. So that's the reason you want the override on the aircraft. Now, I've seen guys fly 14s on a very simple radio system, but they're losing a lot of their functionality of this aircraft. So they're not able to sweep their wings back. When your wings sweep back, you can't have your flaps working, you can't have your spoilers working. Your plane basically goes to tailerons and rudder is all that works when your wings are swept back. So it's a bit of a different situation. And the other thing we do is we use our Cortex to make sure we have control over that as well. So if we go into our gyro menu, Delta Elevon mix as well. So we go into our gyro menu. So we've got all of our flight modes set up on our regular flap switch or flight mode switch. And then we've also got another bank for the wings sweeping back. So this goes in the second bank of the Cortex. You can see it goes on the positive side, negative side. The positive side Basically what we do with that positive side is we have control to go into the gyro and say, turn this channel, this channel, this channel off, and only have gyro control on the ailerons and the rudder as an example. So that's the reason why that is set up as well too. So there's a whole lot going on this plane, and we will dive more into it as we go into the programming. All right, just updating everything, and I figured I'd show you guys the central box stuff here. If you're a Jetty pilot, you may not know this, but with all the devices, you just plug the adapter into your Rec 7 as an example. But when you're dealing with central boxes, you need power. So normally there's a port that has like a USB signal on it. So that's the one you go into. And then as soon as you add power, it'll get picked up on your screen. So that stuff is all updated. All right, so I'll show you the basics of our initial setup here. So we are going to set this up on dual path just for simplicity for the owner. So we're going to have receiver 1 and receiver 2. Now there are some important things as you go through this that you don't need to do right now. So we just need one receiver right now. So we're just going to label that receiver as receiver 1, which is our primary receiver. We're going to take that receiver and we're just going to set it aside for now. We want to keep the initial setup nice and simple, so working around everything and plugging servos in and everything is easy. The other thing we're going to do is our R3 that we're using for on-off. We're just going to set that aside as well too, because it's not needed to actually make this all work. So we've got our program set up here. We're going to go into advanced properties, wireless modes trainer. So we're going to keep this in default mode. Default is just one primary receiver. So we're going to pair this. So we're going to put our bind plug in our EXT port. We power up any other port and we pair the primary module. You want to use this receiver? Yes. Pull our bind plug out so it doesn't beep at us. Now the first thing I want to do with these receivers is I want to get them set up. So we're going to go into our model, device explorer, go into the Rec 7, and we're going to go into general settings. We're going to drop the output period to 11, low voltage alarm to 6.5. That's kind of the standards that we use. Fail safe, we're going to disable. And alternative pin configuration, we're just going to do E1 as EX bus, E2 as EX bus. So now everything's set up standard on this receiver. We're going to keep all the normal outputs, and this Rec 7 is ready to go. So now how do we set the entire plane up? Well, we're going to be plugging our servos into our central box just to allow or have access to all of our ports. So we want to make this a nice, easy setup. So we're going to disable power from the Rec 7. We're going to get a warning on our radio, which is fine. We'll clear that. Now we're going to take our E1 port on Rec 7 and we're going to go to RX1 on central box. Now when we put power to this, it's going to turn on right away. So we'll do that so you guys can see what's going on. So now it's going to bind with the radio. Warning, low voltage. 4.79 volts. So it's supposed to be seeing a 3-cell battery. The voltage is also set very low right now. So now we want to go into our, we'll turn the volume down, want to go into our central box, and we need to set the central box up. So we're going to go into general settings. We'll go to output period 11. You don't want to use auto. Okay, so we'll keep all those the same for now. So voltage setting, we're going to keep it on basic, but we're going to bump that up to 8.4 volts. So remember, we set our warning up on our Rec 7 to be 6.5, and it was only outputting 5.5. So we'll just go through everything else here quickly. So alternative pin configuration, we're going to keep all that the same. Failsafe, we're going to leave. Servo output mapping, we're going to leave as default, so that's fine. Telemetry we'll leave as all that's fine. Telemetry min-max. Now I like to do my clear switch on volume off. So that's P8. So when P8 goes down to the bottom, it gets a check mark, and that clears your telemetry from the central box. Okay, so that's fine, and that's basically it. So now we'll unplug this. We need to charge that battery. And we'll plug in, hopefully, a better charged battery. All right, so we've got our initial setup done here, and on everything, I've gone in and I repopulated our sensors. So we had all the old sensors in our telemetry data. So I come to this screen, hit auto, and that erases all the old stuff and puts in new stuff. So now it'll clear all the old stuff out, so that's fine. We'll let that do its thing. Now the other thing we want to do is we want to adjust what's shown up the top here. And this is kind of one of those important things when you're putting a plane together. Okay, so we'll go to timer sensors, we'll go to main screen, and telemetry on the top bar. So it defaults to flight mode. We're going to change that to telemetry, and we're going to go to central box, amps. So now it's displaying amps on the top of the radio. So why that's important is that's the amps that are being outputted on our central box. So if we take a test servo here, we'll go into port 1, which is aileron 1. So we'll plug that in. It hasn't been populated yet, so let's do that again. So we're going to go into timer sensors, main screen, and we need port 1 amps. So when you're doing this, you want to only have one battery in here. So that was amps on this side, and right now we're displaying amps from this battery here. So right now with the stuff running in neutral, we're at 0.15 amps. Now if we take this servo and we stall it out, you'll see that climbs to almost 1 amp. And as we operate this, it climbs above 1 amp. So it's a handy little setup tool. I like to keep that on there anyways to see the amperage that's being drawn from the system, or drawn from the system. So that, guys, is kind of our basic setup here. Now we're not going to really do anything else on this main screen for now. We can keep it just basic and populate it afterwards, but we've got 3 telemetry screens here from our previous setup. So we'll also, I guess, clean this up a little bit as well. So we'll go to displayed telemetry and go down here and just delete all of these items. So that's fine. We can come in here and populate this stuff. So telemetry, let's go with voltage on 1. Telemetry, voltage on 2. So now when we go to that main screen, we can see that this test battery is at 7.4 volts. Just to get some basic information from the central box. So that's our basic setup now. Now the last thing is when we want to turn this on and off while we're getting things programmed, that's where the bind plug comes in. So rather than having to use your switch and your locking switch, if that's what you use from your radio, all we need to do to power this down now is plug in a bind plug. As soon as you do that, everything's turned off. We'll get our warning shortly. And there we go. So nice little trick for you. And that definitely qualifies for a tip time. It's been a minute since we did a tip time, and that tip time has been brought to you, of course, by trusty bent screwdriver. All right, so next step is to prepare our servos for installation. Now, here at the shop, we run all of our servos through a burn-in process. So to do that, we typically use our jetty box, which is a very handy device, and we put them through 990 cycles of movement. Why 990? Because that's the max that this guy goes up to. So I'll show you guys how we do that and talk a little bit about why. All right, so to accomplish this task, we plug the servo in to the jetty box. We put power into the jetty box. Now this is quite a powerful little device. It does lots of different items, but one of the things that it does is impulse generator, which would be servo centering. And if we hit no, it's going to go to servo cycle. So we'll hit yes. We will hold the up arrow till we get to 990 cycles. And as soon as we hit OK, it's going to start. So the servo is now moving. And I like to have the pulse or the movement amount increase to 500. And then our velocity, which I think is speed, I just bump that up to 30. And that's the numbers we use for pretty much everything. So we'll let this do its thing. It takes about 15-20 minutes. If you're in a rush, you can add a Y cable or a 4 cable and do a bunch at once. We're not in a rush, so we're just going to do these one at a time. As soon as we're done these, we put a check mark on the bottom to signify that they are good to go. Why do we do this? Very common question. So the reason we do it is if something is going to fail from electronics, or an electronic device is going to fail, typically it will happen in the beginning of its lifespan. So running those servos through 990 cycles adds heat to it, adds movement to it. It's not that many cycles compared to like a flight and how many movements you're going to get. But in the past, with certain servo brands, we have had them fail during this process. So they overheat, they lock up, they stop moving, they fry themselves, and the other thing that will show up is movement. So if you take that 599 servo that we just put on the tester at neutral or at 0, and you have a servo arm on there and try and move it, there's very little movement, if any. Some other brands of servos, I say they have built-in expo, because they have a whole bunch of play at center. Or after one series of test runs like this, they started off with 0 play and they may have way more play. So those are the things that we're looking for and trying to pick up on. So we'll get our servos done and ready for installation. All right, so just wrapping my head around everything, scoping out all the parts. We pulled our landing gear out of the bubble wrap packaging. So the landing gear has been painted, I'm not sure by who, but it's the nice antique white color. We do have a decent match to this as well too, out of a spray can. And the reason that's important is the new linkages here, you can see the white difference. So this is bright white, kind of antique white, so we'll have to deal with those. And taking a look at the lighting system here, so we've got the full Unilight setup, and the previous owner did pick up some of these lens kits. So this is exactly how we did the lenses on the previous one that we did. Just the kit here is all laid out nicely, and everything looks like it's pretty much ready to go, except our 3 pieces that we need to cut for 2 on the tail, 1 on the pod. So nice to have these as well too, so you don't need to make them again. And that's the lighting kit. So, and I believe these are titanium pins for the landing gear as well too. So just going over everything and making sure we've got a game plan in place. So I think the first thing we're going to do is we're going to separate the nose of the aircraft to open that guy up. So we'll undo our bolts holding the nose section together. That should slide out nice and easily. And we're pretty much going to start from the tail end and work our way forward like we normally would. So there's lots of things going on in the back end here, but let's get that nose separated first. All right, so we've got our front end removed, and the front end of this aircraft's pretty straightforward. There's only 4 bolts holding that together, and then 2 on the side. The 2 side ones go into the intake right there, or the intake section, and when the front comes off, you've got full access to the front tank here. So the way we normally set this stuff up is we're going to have pretty much most of our air equipment and fuel and everything sitting right in this area right here. So I think previously what I did was I made a plate sitting in this area. We're likely going to duplicate exactly the same thing. And do me a favor, guys, about 50% of my viewers are not subscribers to the channel. So if you are watching this and you have made it this far in the video and you're not a subscriber, it's free to do so. Hit the subscribe button down below. That's how you can support the channel without costing you anything. And then from memory, I'm pretty sure that we had the central box sitting right in that area there. And I believe there's a decent amount of clearance when the cockpits go in. So I'll probably have to look up some pictures, but I think that's where we do it. And the front gear and everything, that's all sitting in this area, so it doesn't interfere with any of that stuff there. And again, I'm pretty sure that we put the Cortex here as well too. So I think that's kind of the general layout. The nice thing when we're redoing an aircraft like this is a lot of those ideas, I think they're pretty solid from the original one, but we're going to repeat a lot of it, and then we can make small changes as needed. So we've got the back end of the aircraft all stripped down, so the pipes are out, turkey feathers or tail cones are off. In order to get the tanks out here and do our bung fitting and vent fitting and everything, we've got to take the swing wing out. Now the swing wing out is already out, so that's a good thing, and we'll have to take these tanks out as well too to do our fittings there. Now, one of the important things with this the swing wing setup here is the amount of space that you have to get everything installed. So you can see the two slots right there. Those are where the big carbon arms come through, like this right here. And then one of the primary locations for the landing gear to mount to tie everything into is that area as well. So you can see the large bolts. That's where they go through on the landing gear right there. So the structure, just like the big one, once it's all bolted together, everything's tied into each other. So you got the swing wing tied into the formers here, tied into the landing gear tied into all those things. So there's lots going on in this area, but it does all need to come out in order to have access to everything. So some of the stuff we need to work on in the back end is air cylinders. Now I've already taken apart these air cylinders and I've pressured them up, but I'll show you what we do. So we've talked about this in other projects. You want to make sure that your nipples there are high-soled or red Loctited. Now for many years now, the Skymaster kits, it seems like those nipples are coming high-soled. Now on the recent kits we've experienced, there being grease on these air cylinders already. So it's nice to open these guys up. You unthread the one end here and you can check and see if the cylinder has grease on it. Now you want to use silicone grease, so I would typically install this stuff right here, Parker Super O Lube. And I also use the silicone shock oil. So that's what this bottle's for right there. My little extensions for adding it to the nipples on landing gear and door cylinders. So that's the two things that I use. So we've already serviced the ones in the back here, and I filled this guy up. So what I do to fill those up is I take a small shock pump and put 100 PSI in the line, and we have it pinched off with a pair of forceps. Now we'll just leave that pressurized for an hour, 2 hours, and as long as when we take the forceps off, there's still pressure in there, we know there's no leaks. And now that's one way to check the systems as you go through things. So we'll check the door closed system, we'll leave it clamped off for about an hour, and then we'll pressurize the air brake open and leave that for an hour or so, and then we know that our air brake cylinders are good to go. You can also do the same thing on the main doors. Now you've got two sets of main doors. That's all these lines right here, and then those do go forward with these lines here, but these 4 lines are for all the doors in the main landing gear section. And then of course we've got our lines for our gear up, gear down, and brakes. So while we wait to check on this guy, we can start moving into some of our other items in the back end. Now, first thing we're going to be working on is our operational tail hook. So we did this on the previous one, worked out very well, and we'll do the same thing on this guy. So the operational tail hook doesn't need to have tons of angle. It basically sits like this in the up position, and the down position sits like that. So what we're going to do is we're going to cut an access hatch into the side of the mount here, and that will allow us to be able to add a servo. All right, so you might be asking, what the heck is this guy doing? Crazy Canadian. He does not know how to build planes. He only knows how to assemble planes. Well, we got our Pew Pew stick. This is a Pew Pew cleaning stick, and a great tool for this particular issue that we're talking about here. So I'll show you guys what I just did. So I pulled the front tank out, and we need the front tank out in order to get access to everything. But I want to show you here, I'll bring all the little pieces down there. So I want to show you, oh yeah, there it is. So all of those little pieces right there are loose, and they were all on that seam right there. So those are all the little gobs of glue that were on those seams, or on the seam. Why is that an issue? Well, they're probably going to stay in place, but we take a little bit of force with that pew-pew cleaning tool and kind of smack them, and they come loose. So what's the problem with that? Well, if one of those comes loose and gets picked up by your fuel clunk, your suction clunk, it's likely going to restrict your engine and probably cause a flame out. So that is a huge issue with fiberglass tanks like this. So you want to make sure you inspect the inside of your tank and deal with those things before that becomes an issue in the future. It could be 2 flights, could be 150 flights before that happens, or never, but always a good thing to do. Let's dump this out and take a look at the amount of garbage that was in there. Now some of them are so big, I don't even know if we'll be able to get them out. So our final big piece is gigantic. Here we go. Oh, no, it broke into pieces. Maybe now it'll come out. All right, so we got all the pieces out. There's nothing left shaking around in there. And those are all the pieces that came off the inside of that tank. Guys, this is such an important thing. I know a friend who lost an ME-262, a beautiful scale aircraft for stuff like this. So, you know, it wouldn't take much to get like a little piece like this to get sucked up by your fuel clunk and completely restrict that fuel pickup. So, such an important thing to look for stuff like that. All right, and our rear tanks are out, and now these rear tanks, they face like this. So this is the forward portion of the tank. So they've got a nice recess here for the fitting and fuel fitting and everything. And those are sitting right in this spot right there. And then what I did on the previous one is our vent fittings or overflows are right here. Now these are going to come forward to our external vent. So the way that this fuel system is going to work is you're filling your UATs, they fill up, go to the front tank here, this fills up, goes to a vent fitting, that comes back to the 2 fill fittings, and once that's full, the fuel comes out of the vent and goes to the external portion of the aircraft. So that's the tank layout. Now when you put the vents in these locations, when you put the tank back in, you kind of have to tuck the tank underneath like that, and then we can't get it in there because of the bolts, but there's this rounded portion at the top, so the vents will actually be sitting right there and pointing forward. So it's nice hidden way to get the vents installed. And then also before we put these tanks back in, we want to run our line and safety wire it on the tanks. So that is everything out of the fuselage. So it's completely stripped in the back end. It's been about an hour, so we filled up our green line on the air brake. They're still holding air very well. This time I left the pump attached, so you can see there. And if we take this off, there's a little bit of air loss because the pump is now filling this back up. But it's held pressure no problem. So we'll pump that back up to 100 and let it sit for quite a while. So we're back at 100, clamp that off, and this time we'll take the pump off. And now we'll let that sit for about an hour or so. If we come back and there is air coming out of there once we open up the forceps, we're good. All right, guys, and that wraps up video 1 in the F14 series. We did a lot of organizing, a lot of figuring things out, and in the next video, we are gonna get back to rocking and rolling on our installation and getting stuff done. So also wanna give a shout out to channel members. Thank you, channel members, for supporting the channel. Now, if you guys are watching this and you're wondering what channel membership is, there is some links down below to channel membership. It's a paid thing, but channel members get to see our videos early. So as these F-14 videos come out, as an example, we may have 2 weeks of videos uploaded to YouTube, and they get to see them early before they're released to everybody else. So thank you, channel members, for what you do. We love your support. Thanks, guys, for watching the video series. Thanks for tuning in, and the F-14 will continue in the next video.